Hi, I'm Alec Tubbs, and this is my lab report for Lab 2. Lab 2 can be thought of more of an extension of Lab 1 than a new lab in and of itself. The data collection and physical experiment portion of the lab was identical, but the coding portion was changed slightly. Instead of modeling the piece of tape as just a point charge, it was instead modeled as a distribution of charges. In doing this, I found that the resulting electric force when the tape was modeled as a distribution of charges was larger than when it was modeled as a point charge. The physics concepts behind this lab are the same as those that were employed for the first lab, them being Coulomb's law, which gives the electric force, gravitational force, which is the product of mass and the acceleration due to gravity, and the ability of neutral objects to attain a charge. Because the experimental portion of the lab was identical to Lab 1, I just copied over my results from the first lab. I'll summarize them now. The length of my U-tape was 20 centimeters or 0.2 meters. The weight of the tape, given that 1 meter of tape is approximately 1 gram, is 0.2 grams. The sign of the tape is negative, and I know this because I charged a pen to be negative and placed it near the tape and it was repulsed from it. And the charge of the tape, after calculation, I found to be 6.16 times 10 to the negative 9th coulombs. Lab 2 varies from Lab 1 with the coding portion. Instead of modeling the two pieces of tape as point charges, they're modeled as a distribution of charge, with each chunk of tape carrying a charge dq. Given this model, and a separation distance of 1.32 centimeters, which I calculated experimentally, the electric force due to the bottom tape on the top tape is 2.54 times 10 to the negative third newtons. This is greater than the gravitational force, which was 1.962 times 10 to the negative third newtons. Using my model and some trial and error, I also calculated the hypothetical charge that the tape would have to have in order for the electric force to be equal to the gravitational force. This Q I calculated to be 5.42 times 10 to the negative 9th coulombs, which is less than the original Q that I calculated from the experiment due to the point charges, which was 6.16 times 10 to the negative 9th coulomb. To the right is a visual representation of my model. The white arrow shows the electric force pointing upwards. The yellow arrow shows the gravitational force pointing downwards, and the green arrows show the small electric force contributions due to the small charges dq. Now I'll go through the lines of code that are responsible for calculating the net electric force on the top tape due to the bottom tape, given the distributed charges. On line 111, we iterate through each piece of charge on the top tape. On line 115, we iterate through each piece of charge on the bottom tape, calculating the net electric force due to this chunk of charge on the bottom tape on the chunk of charge on the top tape. We repeat this process for each chunk of charge on the top tape, and finally, at the end, we're left with the net electric force on the top tape due to the bottom tape, given distributed charges. In order to do this, we had to make some assumptions. The first of which is that the only two forces acting on our tapes are the force due to gravity and the electric force. The other and most important assumption we had to make was that the charges on each of the tapes were distributed evenly across the tapes. To conclude, I'll answer some of the questions that were given in the lab instructions. First, what if you had modeled each of your tapes as a single point charge, like in the previous lab? If I had done this, I would have found that the net electric force would have been equal in magnitude to the gravitational force, not larger than the gravitational force, which were the results from my model. The reason for this is because in Lab 2, we modeled the tapes as having distributed charges. Instead of all the charges being concentrated in one location, it was concentrated across an area, and thus the electric force pointing upwards came from these small chunks of charges pointing upward and not just one single point charge. Now to answer the second question, why do these estimates differ and which value is more likely to be closer to the real value and why? I already sort of answered this, but these estimates differ because in the first lab, we calculated the electric force due to a point charge. All the charge was concentrated in one location. Meanwhile, in Lab 2, we calculated the electric force due to the charge spread across an area. So there were all these small little charges dq that were contributing to the total electric force, as opposed to just one big charge Q. The value that we calculated with the distributed charges in Lab 2 is likely closer to the real value because in the real world, all charges are point charges. They're spread across the surface, which is how we were modeling it in Lab 2.